Oh, good evening and welcome everybody to the BEAMA webinar this evening. We're going to be covering the AFDD myths that have been surrounding the current technology. This work is a conclusion to the work that the BEAMA members have been doing since the release of BS 7671 Amendment 2. The reason for an evening webinar session is to hopefully be able to engage with the wider audience as well, rather than just doing lunchtime ones. So hopefully we've got some contractors and wholesalers online with us tonight. This session will be recorded, or is being recorded, and will be made available via the BEAMA website within the next day or so following this webinar. I'd like to thank all of you this evening for taking time out of your days to attend this webinar. I do appreciate it, and I'd also like to extend my thanks to the BEAMA panel that we have for you tonight. So my name is Nick Haler. I'm the head of Building Electrical Systems at BEAMA. So I'll be chairing this meeting this evening. The panelists, we have Paul Norris, Manager Codes and Standards from Eaton, Ian Peacock, Technical Manager at Lumen Limited, and Deepak Sharad, Marketing Development and Offer Manager at Schneider Electric. So thank you all for joining. So what are we going to be going over this evening? So I've broken this down into two segments for this evening. Approximately the first segment is 40 minutes. That's me introducing BEAMA, the BEAMA members, talking about a very brief conversation about BS 7671 and the amendments. And then we're going to remind you about the guide, the BEAMA AFDD guide, and the fact sheets are available on the website. And then we're going to get straight into the meat of the webinar, which is about these myths. Segment 2 will be open Q&A session for all those attending. So just a quick discussion about the BEAMA members that have been working on all of this. They're part of the Industrial Single Phase Product Group, or ISPPG as we like to call them in BEAMA. And you can see a range of the product types that we cover in this particular sector. We can build electrical systems on the screen there. We've got a good panel of experts with us this evening. If you want to see more about who are the BEAMA members and who contribute to all of these documents, have a look at within the BEAMA guides, but also you can follow the hyperlink that's on the screen or the QR code for a full list of BEAMA members. Okay, so we now have a lovely video. And it saves me having to talk for a minute and a half about BEAMA, but this is a very good introduction as to who BEAMA are and why we're here.
BEAMA, the UK Trade Association for Manufacturers of Energy Infrastructure, Technologies and Systems. Working closely with government and key stakeholders, we help our members navigate investment and supply chain challenges, growing markets to reach a collaborative transition to a net zero future. We provide a collective voice for our members who manufacture and supply essential technologies for the end-to-end energy system. Representing the supply chain for electricity transmission and distribution networks, we aid the integration of renewables and ensure a safe and secure energy supply to UK customers. Working with electric vehicle infrastructure providers, we champion the electrification of transport. Our work with heating and ventilation equipment enables the delivery of low-carbon heat and healthy living environments for all. We assist manufacturers of building electrical infrastructure to ensure the capacity and safety of electrical services in buildings, accommodating for future electrification needs. We represent flexible energy systems to support the rollout of smart meters, energy storage, and management systems for the delivery of flexible energy services. Together, we can meet net zero. Join our community of members today.
Excellent.
Nick, I think we have a problem. The slides aren't moving forward and the video is not showing.
The video is not showing?
No, slides aren't moving. We're still on the first introductory slide.
Okay. Can you see the slides at the moment?
Yeah.
So if I go back, can you see that slide?
The UK Trade Association for Manufacturers.
Yeah.
You can hear and see that now, Paul?
Yeah.
Okay.
of energy infrastructure, technologies and systems. Working closely with government and key stakeholders, we help our members navigate investment and supply chain challenges, growing markets to reach a collaborative transition to a net zero future. We provide a collective voice for our members who manufacture and supply essential technologies for the end-to-end energy system. Representing the supply chain for electricity transmission and distribution networks, we aid the integration of renewables and ensure a safe and secure energy supply to UK customers. Working with electric vehicle infrastructure providers, we champion the electrification of transport. Our work with heating and ventilation equipment enables the delivery of low-carbon heat and healthy living environments for all. We assist manufacturers of building electrical infrastructure to ensure the capacity and safety of electrical services in buildings, accommodating for future electrification needs. We represent flexible energy systems to support the rollout of smart meters, energy storage and management systems for the delivery of flexible energy services. Together, we can meet net zero. Join our community of members today.
Okay, so quickly on to another couple of slides before we get on to the myth element of tonight's webinar. So it's just a reminder really, AFDDs do play a really important part in additional protection against fire that other protection devices cannot provide. So a major change in the IET wiring regulations this year was the use of AFDDs has changed to being mandatory for socket outlet circuits not exceeding 32 amps in certain types of premises, and recommended for socket outlet circuits not exceeding 32 amps in all other types of premises. I'm not going to go into depth onto that regulation right now or this evening. I think we've seen a lot of webinars and a lot of text on that so far this year. So it's just a reminder slide really. Also that the withdrawal of Amendment 1. So just a reminder that Amendment 2 was released in March of this year. However, on the 27th of September, Amendment 1 remained current until that date. So now you must be using Amendment 2. Now, the team have been working on a number of fact sheets. We've broken down the topic of AFDDs into easy to read bite-sized segments. And there's a list of fact sheets you can see on screen there. These are readily available and free to you to download from the BEAMA website. So please feel free to do that. There's a QR code there. And following this particular webinar this evening, one of the final documents is the myths that will be available as from tomorrow on the website. So we're going into the myths and facts. So we've got 10 myths to be going through this evening with the panel. I'm going to read out the myth and I'm going to pick on a core panel member, and hopefully they can contribute and answer the questions for us and clear some of this up. So first one, an AFDD is not required for a parallel arc fault line to neutral, as this can be detected by an MCB. Right, Ian, would you be able to help us out on this myth?
Okay, yeah. Well, AFDDs are designed to operate where high impedance fault occur. For example, it might be the damaged insulation between line and neutral. And that's versus MCBs, which actually require low impedance fault conditions to operate. So, for example, a short circuit. It's really dependent on the magnitude of the arc fault current. The fault current here that's required to operate an MCB would be much higher than an arc fault current, for example, which can cause ignition of the combustible material.
Okay, thank you, Ian. Okay, moving swiftly on to the second one then. Ad hoc tests show AFDDs are not tripping correctly in consistency. Now, we might need to explain what these ad hoc tests are, but Paul Norris, if you wouldn't mind helping us out with this one, please.
Yeah, sure. Thanks, Nick. Yeah, I mean, I'm sure you have seen online a number of ad hoc and DIY tests being performed, but they've been conducted in an uncontrolled and arbitrary methods, or using arbitrary methods. It may be assumed that any form of arcing should operate in AFDD, but that's not the case. It is essential that valid tests, and in terms of detecting arcing, these can be quite complex, but valid tests are performed in an accurate and repeatable way as prescribed by the relevant product standard, and in this case BSEN 62606. And such tests really should be undertaken by qualified, competent persons within a suitably equipped test facility as well. In other words, persons who would have an in-depth knowledge of the product standard and the test methodologies applied, and also using calibrated equipment suitable for the tests that are being undertaken. Now, product standards establish a common and repeatable set of tests to demonstrate product performance, and those are essential. So there's a common set of rules, if you like, used by manufacturers. Failure to test according to the product standard will produce inconsistent and erroneous results, which will certainly be misleading, and will, you could look at some of these tests online and think, oh, the AFDD isn't working. Well, they haven't been tested correctly. So it's essential that correct testing is undertaken. Otherwise, you will get those erroneous results.
Okay, some of these videos are now quite old as well, aren't they? These are 3-4 years old, some of these videos. So some of the products they were testing.
Yeah, they are indeed.
Okay, thank you. Excellent. AFDD size, algorithms, indicators, and configurations are required to be standardized. Right, this one's opened up to the whole panel, so maybe Deepak wants to kick it off, but it's a panel discussion, this one, if anybody wants to add to it.
Yeah, interesting one, Nick. So I suppose there's a few elements to start with on this one. So I think, arc fault detection devices, they're used worldwide in a variety of different types of systems. There is variations in terms of standalone units, add-on units, combination type units, and all-in-one technology. So they could be coupled with MCBs, RCD technology. So there is inevitably some variation, and then because of that, it's unavoidable that the devices will differ depending on which manufacturers they come from, but ultimately they will provide that level of protection for arc fault detection, within whichever guise it is. I think obviously we've got the product standard itself, so BSEN 62606. So these devices are designed to that product standard, manufactured and tested as well. So there is an element that there is standardization in terms of the product, in terms of protection, manufacturing and testing, but some elements, obviously there's not a requirement for standardization. So if you start to sort of go on to a little bit more in detail around algorithms, there will be variations from different manufacturers, and they're there obviously to ensure that they're operating correctly, avoiding unwanted tripping, etc., that could be present in arc fault detection devices. So your algorithms can vary from manufacturer to manufacturer, but we're all working in terms of the product standard of 62606. I mean, I open that up to the rest of the panelists. Is there anything else that I think we need to add here?
Yeah, it's true to say at the moment that AFDDs coming from different brand manufacturers have got slightly different philosophies in the way that they're communicating their information as well in the event of a fault. So, I mean, certainly the AFDDs that I've seen and been used to so far, they're not just an AFDD. They do perform other functions as well. So, the most common ones becoming an AFDD as an integral part of an RCBO. And where those products exist, manufacturers have got different ways of communicating the information depending on the type of fault that the device is trying to clear. So if it's an overload, or if it's a residual current fault, or if it's an arcing fault of some kind, it may give a different coloured light or a flashing sequence or something to communicate what's actually cause tripping of the device, and that's where I think, you know, there isn't the standardisation there just yet. But that's not part of the product standard. That's not part of the 606 standard, is it?
And I think that's a really good point. And you know, we're probably fairly early on a journey in this, in terms of standardization. So yeah, there's inevitably going to be some level of evolutions coming through. I think exactly what you said there. We've got a level of visibility on the device itself that starts to give us an understanding of what scenario, whether it's operational, whether it's a failure mode. Some devices have now started to even communicate that on digital platforms. So evolutions are inevitable, but I think we've got obviously the regulation in terms of product standards that we've got devices that are adhering to, and that's really important, that, you know, that the device is designed, manufactured and tested to the product standard.
Yeah, I think as you guys have said, I mean, basically the product standard gives a baseline for product requirements and performance, how the manufacturer applies their solution to that product standard is entirely up to the manufacturer. So the important thing is that that baseline is there, and to a certain extent comes back to the previous question about testing. That they're all tested to a common format, if you like, or a common baseline, and it's up to the manufacturer how they apply that. And you will, although other products may look very similar internally, there are still elements of differences between product designs, and it's always going to be the case. So yeah, it is up to the manufacturer how they apply the solutions they've designed.
Okay, thanks everyone. I think that was pretty in-depth coverage of that question. Okay, all right, let's move on to the next one. All ready?
Yeah.
All right, AFDDs could be beneficial only in some scenarios, e.g. aged cabling. Okay, so I'm going to pick on Ian again. Let's go back round the circle. Ian?
Okay. All right, so AFDDs do provide protection for aged cabling, but they also provide a lot of additional protection. So we're talking about things like rodent damage, pierced insulation, kinks or breaks in flexible appliance leads, incorrect wire stripping, there's cracked or crushed cables, deteriorating insulation. There's a number of different elements here that cause arcing faults over a period of time. So it may not be something that generate instantaneously, but it may develop over a period of months or even years. Installers also need to consider the types of cables and flammable insulation materials that they use, or they use within the installation. But I think in all cases, the BS 7671, it requires the prevention of ignition and propagation of fire.
Okay, I think it's important to note as well about from the socket outwards as well. It's not just about from in the inside, the structured cabling inside, is it?
No, one of the big things we found was as well, defective plugs and sockets. So we're not just talking about the fixed wiring in installation, the wiring that's buried in the wall. We're talking about the plugs and sockets themselves, the trailing leads that connect there to the appliances. They're at most risk because they're exposed. But certainly plugs and sockets over a period of time, they, you know, as you insert and pull out, they can become worn. I've certainly had an occasion here in the factory where overloading of a plug and socket over a long period of time with a fan heater caused a burnout on the neutral pin, and that was detectable by arc fault detector. It caused a charring and a breakdown in insulation there. So.
Okay, so a good solution for retrofitting as much as new builds as well. Yeah. Okay. Anybody else want to add to that one? Oh, good. Okay. Moving.
Covered the limit, but I think there was also loose connections as well. So when you've got aged equipment, that, you know, we've seen that example as well, where we get that extra level of protection where there could be a loose connection.
Absolutely.
So next one, there is a misleading view being communicated within the industry that the use of such terms as recommended, additional, and specified in BS 671 demote the importance of the requirements for AFDDs within the associated regulations. So I'd like to ask Paul, if you wouldn't mind, to answer that question.
Yeah, okay. Yeah, there's a misleading view being passed around, but this is not the case. Such terms are used extensively throughout BS 7671. They're used an awful lot, and there's no suggestion that use of any of the terms denotes any of the requirements of any regulations that apply any of the three terms. Requirements and recommendations within regulations using such terms must be applied appropriately. There's no kind of get out thinking they don't matter. Care must be taken to ensure that the regulations are applied as written and not based on misleading interpretations of the regulations. Now, in the case of Regulation 421.1.7, covering the requirements for AFDDs, two terms are used, shall and recommended. Now, shall is pretty self-explanatory. It's a requirement. It must be done. It must be covered, if you like. Whereas recommendation, well, recommendation in the definitions within 7671, it says recommendation is an expression in the content of a document conveying that among several possibilities, one is recommended as particularly suitable without mentioning or excluding the others. So what it's saying is, where there may be options to meet the requirements of the regulation, the stated recommendation option is particularly suitable. And the table that is now on the screen describes these verbal forms that may be used to express normative and informative elements. And recommended means, it basically says it should. And you've got to ask yourself, if not, why not? How else is the requirement met? If you're not following the recommended route, how else is that requirement met? So these terms are important, and they're not demoted. As I say, they are used extensively throughout BS 7671, and a good understanding of the terms is very important to the designer and installer.
Thank you, Paul. Quite a detailed answer to that one, but it's a really important topic as well. Thank you. So on to the next one. AFDDs will prevent all fires caused by electrical faults. Big statement. Okay, so open group on this one. So it's a panel discussion. Ian, you got any thoughts or comments on that particular myth?
I think, well, AFDDs are primarily they're designed to detect and disconnect dangerous arcing faults that can't be detected by other types of electrical circuit protection devices. So they're definitely an important additional protection for the prevention of fires that are caused by electrical arcing faults. I mean, AFDDs they're not the cure. They're not the be all and end all silver bullet. I don't think anything's going to be. But they certainly are going to provide you with a lot more protection than you can get currently by just a standard MCB, RCBO, or RCD type device.
I think that's a key point, Ian. I think it's an additional level of protection that we've not had available to us before. We've not used it in many years gone by. This is an additional layer of protection above and beyond what we've become familiar with. I suppose think about the journey where we moved from MCBs to combination of RCD and MCB. We resulted with the RCBO. This is now an additional layer above and beyond that. We talked about the combination type devices earlier, where you've got a miniature circuit breaker and RCBO coupled with arc fault detection technology. So this is a complementary additional level of protection. And I've had these questions where, can you use arc fault detection products on their own? Well, it depends on the circuit, but where you would need to have short circuit overload earth leakage, then no, you would need to use a combination device, or a combination of individual devices to give you that level of protection. So I think you hit it, the nail on the head when you said it's not a cure-all, it's not a silver bullet. So I agree with you there, Ian.
Anything additional, Paul? Any comments on that? Agreeing with you?
I think the guys have covered it. It really is. They're not a panacea for all issues. There's circuit breakers for certain issues. There's RCDs for other protection methods, and AFDDs are kind of, as has already been said, are an additional protection and provide that they fill one of the gaps, if you like, in the protection methods that we have. And it's good that we've now got a solution to one of the causes of fires that we've never had before.
Good answers, guys. Thank you very much, everyone. Appreciate that. Right, AFDDs are expensive and cost prohibitive. Okay, Paul. Mr. Norris, what do you think about that one?
Well, we've it's an interesting one because it's a new technology, and if you remember back to RCDs and RCBOs, they were, when they first came out, were quite expensive as well, to be perfectly honest, and their cost has come down quite considerably, and it's a matter of scale, I suppose, to a certain extent, and availability, and as these become more used, then there'll be opportunities to reduce cost, and I wouldn't say the cost prohibitive. You've got to compare it against what you're actually protecting, the risk if you don't provide the protection. And it is very interesting that we're very willing to spend an awful lot of money on things like our new iPhone, but then when it comes to thinking about protecting my house or my installation, well, that's too expensive. So yeah, it's got to be really put into perspective.
There's a significant technology intelligence in these devices above and beyond previous circuit protection devices too, isn't it?
Oh, indeed. I mean, we're talking about quite high-tech products, really. There's significant level of investment in developing that technology. As I say, new technologies tend to be expensive. But they will reduce, as we've seen, as I mentioned, we've seen with the RCBOs, and it does seem that way now, but over time, I'm sure that will change.
Thanks, Paul. Okay, AFDDs may cause nuisance tripping on conventional arcing from brush motors or switching devices. This is a panel one, but I'm going to kick that off with Deepak, if you wouldn't mind, if you've got any comments on that particular myth.
Yeah, I think in one element it does come back to the technology, the algorithms. Many of the manufacturers that will be bringing products onto the market, we've done a lot of resilience testing. So there's that element to sort of consider, that we ensure that we're testing with real life scenarios to ensure that we're not getting inconveniences caused by nuisance tripping. I mean, one of the elements is that arc fault detection devices are designed in such a way we're trying to avoid any of these scenarios. The product standard we come back to again, BSEN 62606, it does include tests that ensure that there is unwanted, we're looking at unwanted tripping with typical loads and that it's not occurring in real life scenarios. So, there's already inherent in the product standard some elements that cover this.
Yeah, that's can I add to that? It's true to say in the 62606 standard, there are tests that are specifically there for what we call immunity against tripping by things that appliances that do produce sparking during normal operation. So, for example, your portable drill, switching on and off the light switch, but also things like masking tests as well, where if you do introduce an arcing fault in say in the fixed wiring, for example, and you do have these appliances running at the same time, so you might have your vacuum cleaner on or your portable drill or something, the AFDD is designed to be able to see the arc fault that's happening and not be obscured or masked by the fact that the portable drill or the vacuum is running at the same time. So there are, I mean, these tests form an important part of the standards.
Yeah, and I think, I mean, as the guys have said, there were specific tests for common loads, if you like, or loads that would be protected by an AFDD. And I think it's probably worth mentioning that in addition to that, there's also a range of EMC tests that the product has to undertake as well, to ensure that they're not affected by what we could call normal phenomena of the system, so that any signals, any disturbances do not operate AFDDs when they shouldn't.
Okay, so yeah, we've talked a lot about there testing and so on. Yeah, thank you. We'll come on to that later. Got some other.
Yeah, we have talked a lot about testing, Nick, and that's because there's an awful lot of testing in these product standards. You know, these products do not go to market kind of on a whim, as it were, on a wish that they're going to be okay. There is a serious amount of testing behind these products.
Yeah, the investment's huge from manufacturers, the time, the skill sets involved in all of this. Yeah, so quality products for sure. Ian, what was you adding to that?
I was saying discussion there. Period of time as well. I mean, it's, you know, it takes a long time to get something to market and design and pass through all these tests. So it is not a, you know, it's not a quick thing.
Yeah. So when purchasing devices like this, you know, it is really important to understand. Don't just look at a piece of paper, a certificate. You know, if you're a wholesaler buying these types of products, or even a contractor, you know, buy quality products. Be careful what you buy. You know, you pay what you get. You get what you pay for, should I say? Okay. All right, last one before we go on to Q&A. So AFDDs require a minimum load to function correctly. I'm going to, Ian, anything on that?
Well, that's true. That's actually true, yeah. I mean, like, if you say all circuit protection devices have got some predetermined operating threshold, you've got a fuse rating or an MCB rating or an RCD tripping current. It's true that, I mean, AFDDs do need a minimum load current to flow in a circuit of 2.5 amps. Below that, it's not deemed that it can create enough energy to create an arcing fault that will cause ignition. So there is a minimum load.
2.5 amps. Any other comments on that one?
Yeah, I mean, for series arc faults, you could think, oh, you know, am I going to get 2.5 amps? So would I need to protect the circuit? But there's also the issue of parallel arc faults, and those can be well over 2.5 amps. It's very probable because you'd have a relatively low current load. So it's important that we realise that there is a load current limit, if you like, but it's important to realise it's not just one type of arcing; it can be series or parallel.
Okay, thanks everyone.
Certainly, Nick, playing with bits on our test bench here and just varying that load current. I mean, when you start, you can see an awful lot of difference if you've got a visual of the arc. If you put a very low current and it's tiny and you can see the energy, but if you start putting 6-8 amps on things, that energy suddenly becomes a lot higher and everything becomes a lot hotter and brighter, and it really does make a hell of a lot of difference.
Okay. Another one. AFDDs are available for single phase circuits only. Who wants to pick this one up? Single phase only.
Okay.
Go on, then, you put your hand up.
Okay.
Well, good at it.
The product standard, the 62606 standard, it does cover 3-phase and single-phase AFDDs. So they're in the standard. The availability does depend on the manufacturer, of course, but it's important to note at the moment the BS 7671 Amendment 2, I think it's specifically regulation 532.6, only requires AFDDs to be installed on single-phase circuit. So hence that's where most of the availability is going to be, I guess, right now.
Yeah. Okay. As time progresses and develops and things change, you may see manufacturers bring 3-phase devices onto the market. Are they available in the States, 3-phase ones? I know the States do, the United States do, well, they don't call them AFDDs, they call them something else, don't they? But possibly over there.
Yeah, arc fault interrupters.
That's it. That's it. Right. Okay.
AFCI is arc fault circuit interrupters, as it happens. Yeah.
Right. Thank you, gents. That was good timing, actually. We're on to Q&A session, and we've got quite a few people online, but it's pretty quiet on the questions. I do have one, and it is actually, you know, it's a spot-on question. I was going to touch on this earlier on, but I'm glad they've asked the question. I'll read it out and be interested to see what BEAMA members have got to say about this. So, ESEN 62606 may provide a consistent testing standard. However, this does not appear to mimic real life scenarios. How, I'm trying to scroll through the text here, how can this be addressed to provide a more realistic test and therefore consumer confidence in this, increased consumer confidence in this new technology? Now, I know this has been a big topic in our AFDD ad hoc working group. We've been talking about this way. And we've been answering a whole host of questions from various people across the industry. So open to anybody in the panel. Does anybody want to touch on real life, real world scenario testing? No, okay. I know people remember this. Like I say, this has been brought up by. We've seen a number of articles in the last year on this topic, and certainly, and I've witnessed tests at BEAMA member sites on real world testing examples. Like people have invested not just on 62606, but they've taken more. That, like Paul said earlier on in the webinar, these are base level, these standards. They, you know, we all have to abide by these, but you can go above and beyond. And people recognise that, okay, these questions have been raised, so real world tests have been conducted. And you're gone.
I mean, certainly, I mean, for us as a manufacturer, I think probably the same for other manufacturers also. For quite a period of time, you know, we've installed these products in our own homes, actually, as engineers and doing R&D and trying to understand what happens in the event of, you know, and certainly in our own experiences. Okay, I mean, you know, I can't say that I've come across a couple of instances, certainly, that may spuriously trip a device. But you know, I've had, certainly in my own home, I've had these for probably at least the last 6 months now. You know, across all of the power circuits, and we've been playing with all kinds of loads, whether they be, you know, all of your, not just anything you plug in. You know, we've been playing with electric cars, we've been playing with Wi-Fi type stuff, we've been, you know, and trying to understand if things do cause issues. And I mean, this is, honestly, the issues have been few and far between. I wouldn't say they've been completely whiter than white, but few and far between.
And I think, you know, that's a really good point. There's a lot of complex testing that's taking place on these, and you know, most manufacturers have spent years ensuring the integrity of their devices. I mean, we've had products available in other countries for 4, 5, 6 years, and exactly that point is that there's been a lot of resilience testing. There's the product standards that we're working to ensure that we're covering those dangerous artful scenarios. I think we've got a lot of installed base already out there. It's new for the country, it's not new for the world. So I think Nick mentioned it earlier that there are countries that have been using this technology, whether termed in a slightly different way, so it's an artful circuit interrupter and so forth, and we term it artful detection device. But the technology is not brand new; it's been available for some time. The resilience testing was really important because of the type of loads that we have in the country can vary and differ. And exactly as you said, Ian, I've got it installed in my house, and I've had no issues in terms of nuisance tripping. So I'm quite happy in terms of the resilience testing that we've done as an organisation. And it does offer me peace of mind that I've got an extra level of protection above and beyond a miniature circuit breaker or an RCD or an RCBO, combining the two, that gives me that peace of mind.
Yeah, I think you've got to realise that the product standard attempts to replicate the real life, but in a repeatable manner, because real life isn't repeatable in the sense that Eaton or Schneider or Hager or Luden or whoever can go off and replicate that. We need to have a common set of repeatable test methods, and the product standard, I mean, certainly for the arcing aspect of the devices, I mean, it has a cable test and it has a cutting test. So a carbonized cable and a cut test on a cable. And those are to kind of replicate what does actually happen in real life. You think, well, that doesn't happen in real life, but it does, because the cable will get snagged and damaged, so you end up with a break in the cable, such as the cut test or the guillotine test in the standard. Or you may have a bad connection or a damaged conductor such that it overheats and you end up with carbonized type instance. So what the product standards do, and this is the same, whatever the product standard is, it is trying to replicate real life, but it has to be replicated in a manner that is consistent for all manufacturers to apply. So it may not, when you look at the standard, you think, well, that doesn't look like real life. Well, actually it is, because it's replicating in a controlled manner, in a repeatable manner, what is happening in the real world.
Okay, got a number of questions coming flooding in now, which is great. Thank you everybody for sending these in. This one sort of follows on. Do the tests replicate types of art faults in the real world? So we've sort of, we've sort of answered that question with the first question, have we not? Yeah. Another question here. The term additional protection has been used a lot. Is this a defined term in BS 7671? The term additional protection has been used a lot. Is this a defined term in 7671?
Well, certainly the term additional is used a number of times in 7671. I'd have to look at the definitions to see whether it's actually how it's defined. But yeah, I mean, it's used for RCDs, for instance. RCDs can be used for additional protection. So it's it's an addition to other protection methods.
Similar to what we were saying with the fire thing. It's an additional method of trying to reduce fires. Okay, next one. So this one's a couple of questions in one larger question. Do art faults happen regularly, or can we find if they are in development and could arc? So do art faults happen regularly, or can we find if they are in development and could arc?
I think one of the points to remember here, Nick, is that arc fault can be caused by different scenarios. So you could have, for example, a degradation of cable for multiple reasons. So if you've got an issue with, for example, rodents in the attic, they could have degraded the cable insulation, but it could be another cause of that cable to be damaged or or degraded that causes that arc fault. So it's a little bit of an odd one to sort of try and, I suppose, answer. Can you, I think the question was, can you sort of see it before it happens? I think the scenarios are quite wide and diverse.
Some arcing faults are going to take quite a time to develop as well, aren't they? Maybe, I mean, if you've got a loose termination, for example, in a circuit protection device, that conductor may make contact for many months or years without it, and it will heat and it will cool as the load goes through it, and you turn it off, so turn it on and off, sort of thing. So it's over a period of time that fault starts to manifest, and you start to get a little bit of tarring and brittling on the insulation of the cable. You start to get you end up in the end of like a thermal runaway, and so the situation takes quite a time. And once it starts on its way, it's like it's going then. So it's going to accelerate, I think. So once it's on its way. But it may take quite some time before initially it starts itself off.
So you probably won't know that at the initial stage because the damage or the characteristics haven't sort of developed, I suppose, because you've got a connection at that point. The thermal dynamics on that conductor could change over time, brittleness, as you said, Ian, and you could develop an arc or an arc fault scenario later. So to sort of, I suppose, forecast it, a little bit of an odd one for me.
Yeah, okay. Just conscious of the time because we've got quite a few questions here. Do certain AFDD types suit different scenarios better than others?
No, it's a matter of, they're manufactured to a product standard, so they will all have the same performance or meet the same performance criteria. So I don't see that there'll be, we'd use manufacturer A in one scenario, manufacturer B in another scenario. No, there's basically they will all meet the same requirements as per the product standard.
Yeah, Paul, the variations, the variations I suppose you could have is whether you required arc fault detection and short circuit overload protection in one, or arc fault detection, short circuit overload, earth leakage. I suppose they are variations that you could have. But I think if we're talking sort of socket circuits, you're probably going to have a combination of all three.
Thank you. Are AFDDs suitable for EV and heat pump charging circuits and equipment? Good question.
Wow. Okay. Well, an EV socket is still considered a socket outlet, isn't it? So,
yeah.
By virtue of what we're trying to guard against here. Certainly, we've been testing with EVs belonging to ourselves in the home, if you like, and yeah, we found it to be operating satisfactorily.
And I think the other thing, Nick, is that when you start to look at the device and RCD protection technologies and the combination type of devices that are coming onto the market, I think most of them I've seen are type A RCDs in the combination devices. I mean, we've got type ASI, which is our own sort of super immunized type RCD integrated into our AFD. So, there's other topics I suppose it starts to lead on to, is in terms of you've got an electric vehicle charger, there's some level of DC component, what's the earth leakage current, blah, blah, blah. So, it starts to go into a little bit more of a complex discussion around, is it the right type of RCD? What type of leakage current is there on the EV device? Has it got that level of immunity in terms of the DC component? So, interesting question. For me, for example, there are devices that cater for some of those applications, I believe.
Yeah, and in terms of 722, which is obviously for electric vehicle charging installations, it does not modify regulation 421.1.7. So there's still a requirement, so the requirement for AFDDs applies nevertheless. So it's 421.1.7 is a general requirement, and it's not modified by the EV section 722. So yes, it does stand for does apply to EV charging certificates.
Thanks, Paul. Well, I'm going to move on to the next one then. I've heard of arc fault. What happens with an arc AFDD during a power cut? Will it reset? I heard of arc fault circuit interrupters, AFCIs, as you mentioned earlier, Paul, in the USA. Oh, that's a separate one. So sorry. What happens with an AFDD during a power cut? Will it reset?
Well, they're not designed to trip on a power cut unless they have unless you add something like a UVR as an accessory to them, which is a deliberate requirement to open that circuit when there is a power cut, and that's nothing to do with the AFDD. That's more to do with the UVR that you fitted alongside it. So again, looking at the product standard, there's no requirement for it to trip under a loss of power. So BSEN 62606 does not require it to trip.
Thank you. Quick question then on this. Are arc fault circuit interrupters, AFCIs, in the USA, are they the same as AFDDs? So are the two technologies the same?
I think the one thing to sort of, I suppose, keep an eye on and look out for is that the devices that you're using or trying to install in the UK follow BSEN 62606. I think that's quite an important point because as a part of the product standard in the UK, we do actually disconnect the neutral conductor, whereas there are arc fault type devices available globally that perhaps don't disconnect the neutral conductor. So, be conscious that your devices that you're looking to install or purchase follow BSEN 62606. I think some of the arc fault circuit interrupters may not interrupt the neutral. Just it's something to be conscious of, that it's compliant for the UK and not another country.
Yeah, you've got the obvious thing with different as well.
Sorry, Nick.
So the other
isn't
thing,
there the obvious thing with US voltage?
I was going to say the voltage in the US is only 120, so their current's higher for the same wattage as well. So,
okay.
I think it's fair to say the same principles have applied. That they are a slightly different design and obviously different voltages for the US. You certainly couldn't bring a US product into the UK and apply it in a UK installation.
Next question. If cable such as LSF 6491B or LSX, XLPE, FP200, etc. is installed where the insulation does not carbonize, are AFDDs effective?
Remember that AFDDs are not just protecting the fixed wiring installation. So, like we said earlier, they're also protecting the plugs and the socket outlets and the flexible trailing leads of the appliances connected to them, which are unlikely to be of that type of cable. So certainly, yes, for me, they do remain effective. Maybe not for the charring of the. You can overcome the charring of the fixed wiring there, but they've got other areas that they're also looking to protect here. It's not just about the fixed wiring. That's quite important.
Yeah.
Thank you. Right. If AFDDs are to be installed in a commercial three-phase installation, would the unit need to be fitted in an external DB extension, or will they be compatible with three-phase fuse boards for SP circuits?
That's that question again.
So if the AFDDs are to be installed in a commercial three-phase installation, would the unit need to be fitted in an external DB extension, or will they be compatible with three-phase fuse boards for SP circuits?
I think, Nick, on that one, I think, again, some points to remember is that it does vary from manufacturer to manufacturer. I mean, we do already see in the market commercially rated type arc fault detection devices. So in most instances, I mean, if I talk about, for example, our commercial product offering in the UK, we sort of operate at 10 kA braking capacities, and there are devices. I mean, we have one which is rated at that commercial sort of setting. It's got 10 kA braking capacity. There are options to allow you to install it inside three-phase distribution boards. You may be single phasing them. There are other options that allow you to add extension boxes. So, you know, there might be installations or instances where there are retrofit applications, circuits and modifications are being made, existing distribution boards already on site. So you could add, for example, extension boxes and mount them sort of fed from an upstream device. But there are products on the market now that allow you to have a distribution board and install directly onto sort of what we have in the UK as a vertical fishbone type arrangement, an arc fault or combination arc fault detection device inside there. So it would vary from manufacturer to manufacturer, I believe.
Yeah, it's just going to depend on how many modules your device is in the end, actually, whether it can fit on directly onto that frame.
I think we've got time for one more question, if that's all right. They're still coming in thick and fast, so I really appreciate everybody that's joined on tonight. What we will do is take all of these questions. We will put the answers to all of these onto the BEAMA website over the next few days or so. So we will not ignore them. We will come back to you on that and communicate these with you as well. Right, how will an electrician on-site test the devices? How will we replicate from a site tester the relevant scenarios? Final question on testing.
Okay. Yeah, the thing is with testing is, I mean, for testing an arc fault device, you've got to create an arc, and that is not that is not a simple thing to do, as we discussed earlier, and it needs to be done in a controlled manner. Certainly, you can obviously, if it's a combination unit combined with, say, an RCD, or an RCBO, then you can test the RCD elements. But there are no installation testing or testers available to test the actual product. Now you might think, well, that's a bit naff because I want to test the product, but we don't test circuit breakers, for instance. You know, they're 100% tested in the manufacturer's manufacturing facility, and you know, we don't perform tests in the field in the installation. And it's similar with AFDDs. Testing will be undertaken by the manufacturer, and there's no need to test in an installation.
They self-test, though, don't they, Paul? On a defined.
Oh yes, I mean you're right, Nick. Well, they will either have a test button for the AFDD element itself, or they'll have an automatic test, which is performed on every switch on and every so many hours. So yeah, there is a method of verifying the product, as it were, but not in terms of like an RCD. You can test an RCD or its trip level and its trip time, but you cannot do that with an AFDD. There's no installation testing as such.
Okay, it's literally 1 minute to 7, so I'll bring that Q&A session to a close. I'd just like again to thank all those that have taken time out their evenings to join us on this topic of AFDDs. Again, thanks to my panel, and extended thanks to the rest of the BEAMA members that have also contributed to all of this work. Some of the questions and what Paul was just talking about there, the testing devices, that's covered in some of the fact sheets we've got. So I know Lawrence in the background, thank you as well for hosting all this BEAMA tonight. Lawrence has posted some links in the chat. If not, go to the BEAMA website and you will find all the information available there. So thank you very much, everyone, and take care.
Cheers, everyone.
Bye.